All right, we have not done any 5-4 yet, so let me delete that. All right, so I think where we left off last class was these problems. We did sine, cosine, and tangent of these sum and difference angles. So I'm maybe even labeling chapter 5.3 sum and difference identities, because we are adding or subtracting two angles together to get the angle that's given to us. That's going to be different than what we're doing today, because we're going to do half and double angles today. So that's going to look a tiny bit different. I think we talked through these last class, so I'll just kind of put them on the board, but the biggest thing, if you like look at this and you're like, I have no idea what's happening, these are identities on your identity sheet. So the fact that I know that I can make 15 by adding or subtracting two angles, then I'm going to go to my identity sheet and I'm going to plug 60 in for A and 45 in for B, and then use that equation and move on. Same thing with cosine. I could add these two angles to get to 165. So then I use my identity on my identity sheet and just plug and chug. I think last class after the quiz we did tangent, so I'll just kind of show that really quick. Again, this is a sum and difference because that's what we've been working on. That's all we've learned. I could split 195 up to be 135 and 60. So when I plug that into my tangent, I had tangent of 135, tangent of 60, and I plugged those in for my A's and my B's accordingly. I said the hardest part for this one was the fact that you had to get tangent of 135, because that's probably something you don't have memorized. Same thing, tangent of 60, you probably don't have that memorized, so you probably had to do a little bit of work off to the side to get those numbers. Once we did that, I said I was fine if you just left it as -1 plus or minus √3 over 1 plus or minus √3. So I am definitely okay with that. We could spend more time simplifying, and we'll do some simplifying today, but I don't really need to waste more time than that on this. We are going to skip letter D, but I want to get through 2 and 3 if I can before we get into lesson 4.5. All we're doing in number 2 is taking the identities. We're essentially going backwards. So I'm giving you like the first step, and I want you to give me like the problem. So your answer is going to be sine of an angle, cosine of an angle, tan of an angle. So my first question to you is, if we look at this first one at 2A, which does this look like? Does this look like our sine sum and difference, our cosine sum and difference, or our tangent sum and difference? This one looks like sine, right? It looks just like sine. We say sine of A times cosine of B minus sine of B times cosine of A. So I'm going to write, it's going to be sine. Am I going to add or subtract those angles though? Am I going to add 58 and 32 or subtract them? Why?
Because there's a minus sign.
Good, and we have to match the sign. So we're going to do 58 minus 32. The only thing I want to do is actually minus them now. So I do want to go one more step simpler and say sine of whatever 58 minus 32 is. Tired today, 26. And that's my answer. Okay. You guys all right with that? All right, we'll do B and C since we see those. Letter B, which one is that, like sine or cosine or tangent? Tangent. Am I going to add or subtract those two angles? Add, because the signs on top match. So I'm going to do tan of 13 plus 18, and then my answer is going to be tangent of 31. All right, similarly for letter C, I've got cosine of 12x times cosine of 9x minus sine of 12x times sine of 9x. Which one does this look like? Sine, cosine, tangent? Cosine. Am I going to add or subtract these angles? We're going to add them. We're going to do opposite of what we see. So we see a subtraction. I'm going to add them. I know the angles are 9x and 12x, and I know that might seem silly, but you can still add 9x and 12x. It's going to be cosine of 21x, and that's my answer there. All right, let's do the next two. Those two just have some of their parts missing. So this first one says sine, I'll just rewrite it. it says sine of 6 times sine of 10 minus cosine 6 cosine 10. Which one does this one look like? Hint, it's not exactly the same as any of them, but what does it look the most like? It looks the most like cosine. I've got sines together and cosines together. In the sine graph, in the sine identity, I'll just pull it up and then I'll get rid of it so for sake of space. In the sine one, I have it split. I've got sine and cosine, and then I've got sine and cosine. But in cosine, I've got both my cosines together and both my sines together. So that means since I've got both of them together, they're not intermixed. This is like cosine. However, you see how in cosine, my cosine goes first? We got to rearrange this so that my cosines go first. So I'm going to rewrite this as negative cosine 6 cosine 10 plus sine 6 sine 10. We got to respect the fact that that cosine has the negative with it. So we got to keep that negative with that cosine 6 cosine 10. But if you go back to your identity sheet, we don't have negative in front of it. So let's factor that negative out. So now I can actually make sure it looks just like my cosine one. I've got negative parentheses, cosine 6, cosine 10. The plus that was in front of the sign now has to become a minus because we are factoring a negative out. So now I've got minus sine 6, sine 10. That was a lot of work to now say that I'm ready to use the cosine one. You got to keep that negative out front, but I'm going to do negative cosine. Am I going to add or subtract the 6 and the 10? We're going to add them. We're going to do opposite sign of what we see right now. The middle is negative, so we're going to add them. So it's going to be negative cosine of 16 degrees. All right, that one was probably the hardest one because we had to kind of rearrange it. This one's very simple. I'm just going to rewrite it so it makes sense. Sine of 37 cosine of 19 plus cosine of 37 times sine of 19. Sorry, I got caught off. Cut off. Why did I just say that funny? Got cut off on the copier. Which one does this look like? Sine, cosine, tangent? Sine, add or subtract the two angles? Add them. 37 plus 19 is going to be 56. We're going to do this a little bit more today with our half and double angles once we start learning about those. But I just wanted to get a little bit more practice with the sum and difference so we can kind of see, like, make some connections in our brain which ones go. You will always get the identity sheet. You will always have the identity sheet on any quiz or test or anything. I'm not going to ever make you memorize that. That being said, though, you got to kind of be familiar with what's on it to know when to go back and look at the identity sheet, okay? All right, the next two problems we're going to do, we're not going to do letter B, we'll do A and C. These are verifying, so this is still practicing stuff from 5.1 and 5.2, but we are going to use the new rules that we learned in this section. So, and I zoom in on letter A, I've got sine of x minus pi over 2 equals negative cosine x. What I need to remember, we just learned the sum and difference. So we're going to go to our identity sheet and we're going to look at the difference identity for sine. I can plug x in for A and I can plug pi over 2 in for B. You want to take over?
You know what this is also basic.
Okay.
So that the sin,
Sine.
this, yeah, sign. There's different pronunciations, very common. You want to multiply, you see that actually multiply by the negative box over 2. House.
Pi.
Yeah, pi. It's
Yeah.
just divide it.
Yeah.
Yeah.
Pi.
What was that?
I don't know. I don't know. What is he doing in this hallway? Who knows? Do you ever see a teacher like out of place and you're like, what are you doing over here?
Yes, it's so weird.
Like whenever I'm in Loretto, I'm like, what am I doing over
No,
here?
I see an English teacher over here. I'm like,
You're like, what? How'd you make it? How did you know where we are? All right, that being said, what Mr. Gross is saying is not right, but it is just as easy as going to your identity sheet. I'm gonna plug A is gonna be my X and then B is gonna be my pi over 2. So we're just gonna go plug those in to what we have right here. So I'm gonna say sine of X times cosine of pi over 2. Do we match the signs or do we do opposite signs? We're gonna match them, good. So then sine of pi over 2 times cosine of X. Now, that being said, this is a nice problem for us because we actually do know sine and cosine of pi over 2, right? What is cosine of pi over 2? 0. And what's sine of pi over 2? 1. So we can replace, and I might even write that up here if I forgot, pi over 2 is 0, comma 1. So my cosine is 0 and my sine is 1. So I can replace cosine of pi over 2 with 0, and I can replace sine of pi over 2 with just 1. Anytime I can add ones and zeros in, that's actually very helpful to me, because what is sine of X times 0? 0. And what's negative 1 times cosine of X? Negative cosine X. Is that what we wanted it to equal?
Yeah.
We did it. We're done. It's really good. All right, let's look at the one below it. We're gonna do a super similar idea, but this time we're gonna use the sign identity twice. We're gonna do sine of X minus Y and sine of X plus Y. So we're gonna do that same trig identity, but we're gonna do it 2 different times. Do you think you can start it without me? You're gonna plug X in for A and Y in for B. All right, I did mine in different colors so you can kind of see where one starts and where one stops. So the first one became sine of X cosine of Y minus sine of Y cosine of X. And then the second set became sine of X cosine of Y plus sine of Y cosine of X. You guys okay with using the trig identities? Yeah, okay. What do you see? Can you combine anything? Can you cancel anything out? Yeah. Sine Y and cos X, one's positive, one's negative, so those are gonna go away. What about sine of X cos Y plus sine X cos Y? What does that become?
2 sine X cos Y.
2 sine X cos Y. Is that what I wanted to equal?
Yes.
Yes. We did it. So all we're doing is kind of simplifying, combining. And then we are able to get it down all the way to 2 sine X cos Y. It's awesome. Cool. All right, technically that's the end of 5.3. We've done all of this, except this one you will never be asked to do. So you guys are good on 5.3. Oh, let's actually keep going. Let's actually get into our 4 notes, because there's a couple that refer back to what we just did. So I want you to scroll or flip in your notes until you come to number 5 in 5.4. So you're essentially skipping like half of the page we were just on, skip the whole next page, and it's the beginning of the page after that. Number 5 says if sine of alpha is 3/5, pi over 2 is less than alpha, which is less than pi, and cosine of beta is 5/13, 3 pi over 2 is less than beta, which is less than 2 pi, then we want to find these things. And if you notice, these two, sine of alpha plus beta, tan of alpha minus beta, are our sum and difference equations, right? Because we have a plus, which means sum, we got a minus, which means difference. So I want to kind of do these while these are fresh in our head, and then I'll teach you new identities after lunch, okay? What we got to do before we even set up and solve this is let's look at what's going on here. Let's look at my sine of alpha, okay? So we're gonna draw a picture so that we can kind of get a visual idea of what's happening with alpha. Now it says alpha is in between pi over 2 and pi. What quadrant is that? Second quadrant. So draw a triangle somewhere in the second quadrant. And we're gonna label that angle alpha. If I know that my sine is 3 over 5, then that means we know our opposite is 3 and our hypotenuse is 5. So we can label two parts of my triangle. Can you find the third side of my triangle? Yeah. Pythagorean theorem, right? We've been doing this for days now. And this is actually something we're usually really good at. All right, I got that adjacent side is gonna be 4. When I put it on my picture, is it gonna be +4 or -4? -4, very good. And then I'm gonna label these opposite adjacent hypotenuse. And now I could find any trig function, right? I could find sine, I could find cosine, I could find tangent, I could find any trig function based on this triangle now, right? All right, we're gonna come back to that. I'm gonna use that in a moment. Let's do the exact same thing for B. So let's do B, or beta. What quadrant is beta gonna be in? If I'm between 3 pi over 2 and 2 pi? The fourth quadrant. We'll put a little B in there for beta. We'll put our little right angle. And then I know this is cosine of beta, so that means I know adjacent and hypotenuse. Can you find the missing side?
Yes.
Yeah. When I put that 12 on my picture, is it gonna be positive or negative? Negative, because we're going down. And I'm also gonna label opposite adjacent hypotenuse, just so I am ready to go. Now, by just telling you what sine and cosine were for those two different angles and telling you where they are, now I know everything that I need to know about these angles. I'm gonna do sine of alpha plus beta. Now, just looking at this, you're like, I don't know what alpha and beta are. I can't plug them into my formula. Well, I'm gonna tell you right now, we're gonna use our formula and I can know what sine and cosine are for both of these angles by just looking at the picture. So I will have something to plug in, okay? So let's use our identity. So I'm gonna say sine of alpha plus beta. Okay, that's gonna be sine of alpha times cosine of beta plus, because we want to do the same sign, sine of beta times cosine of alpha. Now that I have this, I'm gonna go look at my pictures and I know what sine of alpha is, right? Sine of alpha is gonna be opposite over hypotenuse. Oh, I did color coordinate right. It's gonna be opposite over hypotenuse, so that's gonna be 3 over 5. And then cosine of alpha is gonna be a over h, -4 over 5. You guys okay with that so far? Okay, now we're gonna do the same thing for the beta. We're gonna do cosine of beta, looking at my picture. Cosine of beta is 5 over 13. And then sine of beta is -12 over 13. And now we have actual numbers, so we are going to combine them. I would argue to not simplify yet, because if you do simplify, you may need to multiply later to get like denominators. So we're not going to simplify. We're just going to multiply the tops and the bottoms together. So now I've got 15 over 65 plus positive 48, negative times a negative is positive 48 over 65. And then I can add those two together. 15 plus 48 is gonna be. Is that 63 over 65? Nice. Do you think we can do one more? Do you think we can do tangent really quick before we go to lunch? Okay, let's jump in and we'll do that really quick. So tangent, you have your identity sheet out. Tan is gonna be tangent of alpha minus tangent of beta. All over 1 plus tan alpha times tan beta. When we did this with the unit circle problems, we had to like solve out tangent for both of those angles. But I could just go up to my triangles and do opposite over adjacent for alpha and opposite over adjacent for beta and figure out what those are. So tangent of alpha is going to be 3 over negative 4. Okay. So I got 3 over negative 4. And then my tangent for beta is going to be, come on, negative 12 over 5. I added some parentheses in the numerator because I've got 2 negatives, so I would like to combine those to be a positive. On the bottom, you can just multiply those 2 fractions together, so I get 1 plus 36 over 20. But on top, we should get like denominators, right? So let's multiply by 4 on top and bottom on the second fraction and 5 on top and bottom of my first fraction. You guys are doing great. I'm just gonna keep simplifying this. I'm gonna add my fractions together. The bottom, you might need to make that 120 over 20 so that you can like have something to add together. So I get 48 minus 15 is 33. Okay, 33 over 20 divided by 56 over 20. And again, while you can simplify, I'm gonna argue you don't, because now to get rid of that big ugly fraction, I can multiply by the reciprocal. 33 over 20 times 20 over 56. Is it not 56?
36.
It's 36 plus 1.
Oh, sorry.
And then when the 20s cancel, you get 33 over 56, which you actually cannot simplify, and that's your best. The algebra is the toughest part. All right, that's a good timeout point. Go to lunch, come back by 45. We are gonna do the rest of 5.4 then. I'm gonna just stop this.